Okay, so K4, here's your answer key. Name the chords. Well, remember that a chord is going to be a segment, not a line, not something that has arrows at the ends, but a segment. It's going to be a segment where the endpoints are on the circle. So we have some examples here. AB is going to be a segment where the endpoints are on the circle. You can also call that BA. Notice I put the bar on top in order to indicate it's a segment. We also have segment AE, where the endpoints are on the circle. That's AE or EA. The diameter is also a special kind of chord, where the endpoints are on the circle. It just happens to also pass through the center. So AD or DA, that's another chord. Next, name the central angles. A central angle is going to be an angle where the vertex is at the center. So BCD is one example, or DCB. BCA is another example, or ACB. We also have, technically, the straight angle of DCA or ACD. That straight angle just happens to be a central angle. The vertex is at the center. It's just a straight line as well. Okay, next, name the inscribed angles. Here's new content. The inscribed angles are going to be the angles where the vertex is no longer at the center. The vertex is on the circle. So one example would be like BAD. I could have also named that BAC or DAB or CAB. Another one would be DAE. That could also be EAD or CAE or EAC. Another one would be BAE or EAB. There's actually another angle ABC or CBA. And I think that's it. Okay, so question 1 and 2 were review, 3 was new. Question 4 and 5 are more review stuff. So on 4, if they're asking for the measure of ARCQS, it's important to remember that central angles are congruent to their corresponding arcs. So for example, if this is 55 degrees and this is 55 degrees, that's 47 degrees, and this arc is 47 degrees. Something else that's important to always look out for are the diameters. For example, if QT is a diameter because it's a chord that passes through the center, I also see that RU is a diameter. It's a chord that passes through center P. All of these are going to come in handy to find pieces. Something else that comes in handy is to look for vertical angles. When I have two straight lines that cross paths, remember the angles across from each other are vertical angles, and those are congruent. So if this one's 47, I know that this one's 47. I can also use the diameters in order to help me find missing angles, because if this is a diameter and it splits the circle into two congruent halves, I know all three of these together should add up to 180. So if I subtract the 55 and 47 from 180, I'll get my missing angle. So when I do my subtraction, I get 78 degrees. And now the arc they were looking for is a combination of these two. So the 78 plus the 47 gives me an arc of 125 degrees. Now the measure of arc RQT. Okay, I'm going to erase all this. Measure of arc RQT. So it's an arc that extends from R to T while passing through Q, which means I want to know everything that's included in between. I know I can look for diameters because diameters help me identify 180 degrees. So I can see that from here to here is already 180. So I just really need to add on an additional 47. So this 180 plus this extra 47 gives us a full arc measure of 227 degrees. Okay, number 5. Measure of arc HG. Okay, same situation. If this angle is 23, then this is 23. If this is a right angle, then this arc is 90. If I see that I have a diameter, I know that I have a semicircle worth 180 degrees. So if all three of these, should add up to 180, and I already know one is 90 and the other is 23, I subtract them. So when I subtract the two that I know from 180, I get a missing angle measure of 67 degrees, which tells me this arc is 67 degrees. Now they ask for the measure of arc FEH. So I know I'm connecting F to H, but in order to do so, I have to pass through point E. So again, I can see, oh, I have a semicircle here. So I just want this semicircle plus an extra 23. So the 180 plus the 23 gives me an arc measure of 203 degrees. Okay, questions 6 and 7 are new content. Now we're going to look at our inscribed angles. 4 and 5 reminded us that the central angles are always congruent to their arcs. So this central angle being 55 told us this was 55. And that central angle being 47 told us this arc was 47. Inscribed angles have their own rule. Inscribed angles don't have their vertex at the center any longer. Their vertex is on the circle. So if they're asking me for the measure of angle CED, I'm going to look to the arc that's intercepted by that angle, meaning the arc that fits completely inside of that angle. And that's a 66 degree arc. The angle is always going to be worth half of the arc that it intercepts. So if that arc is 66, this angle is 33. Next, they want the measure of arc DEA. So arc DEA encompasses this entire space, and now I can look to this inscribed angle, DBA. Since this arc fits completely inside of that angle, no more, no less, I know that there's a relationship. If this angle is 96 degrees, then I know this arc is 2 times that. So notice the angle is half of the arc, or the arc is 2 times the angle. That's the relationship. So 96 times 2 gives me an arc measure of 192 degrees. Number 7. Measure of angle FGI. So to follow this rule, this is an inscribed angle because the vertex is on the circle. The arc that it intercepts is 18 degrees, so the angle is worth half of that, making it 9 degrees. Next, we want the measure of arc GH. So if the angle is 39, then the arc that it intercepts will be double that. So double 39 gives me an arc of 78 degrees. Okay, question 8 is review content, 9 is new. So on number 8, I'm back to looking at my central angles here. The vertex is at the center. And what I can acknowledge is that all 3 of these arcs combined make up a semicircle, right? They make up 180 degrees. So really, that's my equation. 4x plus 2 plus x plus 78 equals the semicircle that's worth 180 degrees. So combine like terms and solve. We have 5x plus 80 equals 180. Subtract the 80 to have 5x equals 100. Divide by 5 and get x is 20. They didn't ask us to plug anything in. That's our final answer. Okay, number 9. Actually, I'm going to start with number 9 on the next video.